Okay, we'll solve the following exercise. The exercise is the number 2.8. The sum of the forces Fa plus Fb plus Fc equals 0. The magnitude Fa is equal to 100 newtons and the angle alpha is equal to 60 degrees. Graphically determine the magnitudes Fb and Fc. Okay, the first thing that we have to take into account here is this statement. I think that this is the principal one. Why is that? Because I want to explain what is happening here using these three, for example, these three vectors. For when I want to create a summatory of vectors, then what I have to do is to create, okay, graphically speaking, is to create a resultant vector. How am I going to do this? I'm going to move one of the vectors, in this case this one, and the statement that I have to comply is that this vector must be touching tail with head. The tail of the vector that I've moved with the head of one of the other two vectors. In this case, I'm going to do the same thing right here. And the answer of the summatory of these three vectors will be between these 2 points, in which there is going to be generated a resultant vector, and this vector is going to be the other way around. So the tail of this vector must be touching the tail of one of the corner vectors, and the head with the head of the other vector. Okay, as you can see right here, tail with tail and head with head. I could have moved, for example, not this one but this one, creating a shape like this one, and the answer will be the same. Okay, this is the answer. So when they tell me that the summatory is equal to 0, then what is created right here is a closed shape. Okay, sorry, this is not a straight. Okay, because I have right here Fa, right here I have Fb, and right here I have Fc. As you can see, I cannot create a resultant vector since these three vectors are connected with each other. So this is equal to 0. And once I've made that clear, and that I've met the requirement that these three vectors met the requirement, then what I'm going to do is to start writing down the angles between them. Okay, in this case I have an angle alpha, which is equal to 60 degrees, generated between Fa and Fc. So Fa and Fc has an angle of 60 degrees, and between Fb and Fa I have an angle of 30 degrees, so this is equal to 30. I have this magnitude, this is equal to 100, the magnitude of Fa, and I must find the magnitudes of Fb and Fc. Okay, how am I going to do this? I'm going to start by finding this angle. Why is that? Because I have the other two and I think that it's easier for me. So there is a statement that you have to maybe memorize or to understand, and is that the summatory of the angles within a triangle is equal to 180. Okay, so that means that 60 plus 30 plus the angle that I need is equal to 180. Okay, that means that the angle that I need is equal to 180 minus 60 minus 30. That means that this angle is equal to 90 degrees. So this doesn't look like I've done the triangle. The triangle would look more like this one. Bear with me while I create the triangle, because right here I have a corner, a 90-degree angle. Alright, so right here I have 100, right here I have 30, right here I have 60, and what I need is these two lengths. Okay, what I'm going to do is to create a law using the signs of the angles. Okay, how can I do this? Because I can create a correlation between the magnitude that I require and the angle that it's in front of it. Okay, in this case 100 with 30, this magnitude with this 60, and this magnitude with this 30. That means that the sines law is equal to 100 divided by the sine of 30 of, this is not 30, sorry, this is 90, by the sine of 90 is equal to the, sorry, I'm going to call this FB and this FC, to FB divided by the sine of 60, and this is equal to FC divided by the sine of 30. This is the sines law. Okay, once I've made this, I can find these two values. So what I have to do right here is that I'm going to take this part of this equation and I'm going to say, well, I'm going to write it down once more. Bear with me. Okay, so FB is equal to 100 divided by the sine of 90 multiplied by the sine of 60. Okay, and I can eliminate this. So FB is equal to, I'm going to use the calculator right now. I have to make sure that this calculator is in degrees. So sine of 60 multiplied by 100 divided by the sine of 90, and I have the magnitude of FB. This is equal to 86.6025. I always use 4 significant digits after the comma. And here we are, guys. Here we have, this is the first answer. This is in newtons. Okay, because we are talking about a magnitude, a magnitude in newtons right here. And now I'm going to use the same equation for me to find the FC value. So in this case, I'm going to take this equation once again. By the sine of 30. Thank you for your patience. And then I'm going to do the same thing right here. Okay. And right here I have this, and I can erase this part. I want to make sure that you understand how did I solve the equation. So the magnitude of FC is equal to, in this case, the sine of 30, and that would be all. This is equal to 50 newtons, and that's it, guys. This is how you can solve this exercise. There's one more step though, because I want to make sure that these two answers are correct. So what I'm going to do is to create a shape using a software, in this case CATIA V5. Remember that you have within the channel tutorials about this software for you to analyze, for you to learn how to manage this tool. Okay, so right here I have FA, right here I have FB, and right here I have FC. I'm going to constrain the values. So right here I have this angle, and this angle. Okay, everything is defined, although I wanna create a connection between these 2 points. And when it's in green, the lines are green, that means that everything is defined. So that means that I cannot move anything. Okay, then I'm going to change the values. So this angle is equal to 60, this angle is equal to 30, and this is equal to 100. Okay, and what I need is these two lengths, so I'm gonna create this reference and reference. Okay, as you can see right here I have the answer that we have solved by using the trigonometrical identities, and right here I have the same answer. And this is how, guys, you can solve this exercise.